Good afternoon, everyone. My name is Voni. I am from Water First Lab under the guidance of Professor Amriong. Today, I'm going to talk about the effect of sunlight on microbiological water quality in rainwater harvesting system. My objective is to clear up the misconception about the deterioration of stored rainwater under the exposition of sunlight, as well as the misunderstanding concerning the harmful effect of biofilm on stored water. To reach that goal, I'll be giving a brief introduction in which I'll go through the question, what is rainwater harvesting system? What are the factors affecting the microbiological water quality of stored rainwater? And I will talk about the objectives, materials, and method of our research. Second, I will look at the investigation of effect of sunlight on microbiological water quality and on physiochemical characteristics. Next, I will give some recommendations about the design and operation of rainwater tank. And finally, I will conclude with a take-home message. Before I start, does anyone know that only 10% of the world population have access to the potable water? Due to that, every year, more than 800 of children under 5 years die. And it also increases the gender inequality because instead of taking care of their family or going to work, women spend 5 hours per day to collect water. To tackle those issues, the United Nations set the Sustainable Development Goal, especially the SDG 6, clean water and sanitation. They identify that rainwater harvesting system is a potential solution as an alternative source of water. Rainwater harvesting system is a technology that collects and stores rainwater for human use. It has numerous advantages such as simple technique, lower cost, and a low pollutant inflow. However, it has also its limitations. In fact, uncertainty about the microbiological water quality of stored water make it hard for people to adapt the technology. Microbiological water quality is affected by the possible contaminant, for instance, birds dropping dust on the catchment area, which can be carried inside of a storage tank. The presence of biofilm and the load of total bacteria represented by the heterotrophic plate count and the fecal contaminant and indicative bacteria, as well as the exposition to sunlight of the storage, can affect the microbiological water quality. That's why we set our research objective as follows: to investigate the effect of sunlight on microbiological water quality and on the physiochemical parameter of stored water. Second, to suggest the design and operation of rainwater harvesting tank. With this objective, the method and material when we conducted the experimentation involved an acrylic tank of 34 liters with blue coating that we installed on the rooftop of a building 35. One storage was covered to simulate a dark storage. Here, as you can see in this picture, we hanged a 12 coupon set at a different level, top, middle, bottom, with a fishing line. And In the right of our slide, you can see the picture of the storage, and here the polyethylene coupon. The parameters that we investigate are pH, temperature, dissolved oxygen, total dissolved solid, biomass of biofilm, and the number of viable cells. After implementing this step, this is the result of the microbiological water quality in storage exposed to sunlight. In the liquid part, we can see that the top and middle show a trend of bacteria count which is increasing, then decreasing over time. And for the bottom level, there is a higher decrease of number of cells. Therefore, we can conclude that there is a higher reduction of the number of bacteria at the bottom level. On the surface, here in the left of our graph, we can see that there is an increase and a relatively stabilization of the number of attached bacteria. And the biomass level is high and relatively the same within the water depth. Therefore, the attachment and the secretion of biomass is similar within the water depth. For the water stored in dark, on the liquid part, the top and middle level has an increase during the first week and then decrease over time. However, the bottom level has an increase following by the relative constant number of bacteria. Consequently, it suggests that there is a greater reduction of number of bacteria at the top and middle level. On the surface, on the graph in the left, the top part presents an increase and after a stabilization of the number of heterotrophic plate count, but the middle and bottom part show a slower decrease of bacteria. And within the water depth, there is a low level of biomass. So in conclusion, there is a variation of biofilm within the water depth. Comparing the two results, on the liquid, we can observe a slower decrease of bacteria under exposition to the sunlight. It's illustrated by the graph in yellow here. And when the water is exposed to sunlight, the bottom level has a faster decrease and has a similar tendency to the water kept in the dark. As we can observe, the removal of bacteria in the dark is 10 times faster than the one stored under the sunlight. On the surface, the number of attached bacteria began to decrease in the 7th week when the water is kept in the dark, and we can also observe that the biomass level is higher in a storage with exposure to sunlight. The lower level of biomass implied that the bacteria kept in the dark doesn't produce much more matrix than the one exposed to sunlight. On the other hand, The physiochemical characteristic in the stored rainwater exposed to sunlight, the pH variation is represented by the graph here, and we can observe that there isn't a difference within the water depth, and the pH range from 4 to 8. For the temperature, it ranges from 20 to 29, and the water depth doesn't have any effect on the temperature. For the total solid, it ranges between 27 to 70 milligrams, and the level of dissolved oxygen range in 6 to 9, and it's relatively stable over time. When the water is stored in the dark, the pH, temperature, dissolved oxygen, and total dissolved solid are relatively constant. In the graph, we can observe that the pH was variated from 6 to 9. The temperature range from 22 to 27 degrees C. The total dissolved solids are practically the same as the water stored exposed to sunlight. The dissolved oxygen is lower and range from 6 to 7 milligrams per liter. When we compare the physiochemical characteristic between the exposition to sunlight and dark control, we can notice that pH, temperature, and total dissolved solid are practically similar. The dissolved oxygen is slightly different because the water stored in sunlight has a higher level of dissolved oxygen. This implies that there might be a photosynthesis on this water stored in sunlight. That's all for the result of the investigation of effect of sunlight. Now let's move on to the recommendation concerning the design and operation of rainwater harvesting tank. For storage tank exposed to sunlight, it's better to provide shading if possible, and having a storage with a higher length to width ratio. Then place the outlet between 5 centimeters and 0.5 of the length from the bottom part of the storage. Do not disinfect the storage to avoid killing and disturbing the ecosystem in the storage. To sum up, the microbiological water quality improve during the storage, especially when the storage is kept in the dark. For storage exposed to sunlight, it's better to provide shading and do not disinfect because it's counterproductive for the ecology in the storage. That concludes my presentation. These are my references. Thank you for your attention. If you have any questions, feel free to ask.